Let's actually make some artificial intelligence. We're going to make Skynet. Well, maybe not quite that much. We're going to make a simple enemy that's going to walk towards us and within a certain range that's going to shoot us. So we already made some things here in the previous video where I just gave a brief overview of the entirety of what behavior trees are like. So we have a couple of keys here for self actor, for can shoot, for player, and for the distance to the player. Today we're going to need to give this player a value. We're going to need to give and update a value to the distance to the player, and we're going to need to make a task that will actually shoot a bullet when all those requirements are met. So first things first. We want to, whenever we go through this selector, we want to update the distance to the player. So let's go into our C++ classes here and make a new C++ class, and that is going to be a BT service. We're going to just use the normal BT service as a base here, and we'll call that one BTS update distance to player. I want to give the distance a capital D. And then we're going to create that class, which will create our header file and our CPP file, as we're used to. It's probably going to throw some errors at us because it just likes doing that. And here we're going to make a few variables. All of them are going to be U properties, and we'll mark those as edit anywhere. And the type of variable is going to be an F blackboard key selector, and we'll call the first one self actor key, and then I'm just going to copy over what I pre-prepared for you all. We also have one of those, you can give them a category if you want to, why not. We'll have one of those for the player key and one for the distance to the player. Here we can select the blackboard keys that we'll have on our blackboard and say you're going to read the position for the actor itself from this one, you're going to read the position of the player from this one, and then you're going to write the distance between those to this one. And that we're going to do in a function, and it's important that this is exactly what I'm about to paste in here. So I'm going to copy it over from a different project. It's going to be a virtual void tick node with the parameters u behavior tree components, owner comp, uint8 node memory, and float delta seconds. This is the same as any other tick function on any actor, except of course this is specifically a tick function that runs on a behavior tree service node. So let's make a definition for that, and in that definition we're going to start by making two character references. Let's actually change these to a actors, because they could be pawns, they could just be normal actors. By and large, they're probably going to be characters, but might as well just make them actors because there's nothing about the character specifically that we're going to need here. So we're going to cast that to a actor, and what we're going to cast is going to be our owner component dot get blackboard component. So that gets the blackboard component corresponding to this behavior tree. And from that, we're going to get the value from a key, and that's going to be the self actor key for our self actor, and that's going to be the player key for our player actor. And it's important that you get the selected key name because it's all based on the names. It's looking up names and comparing those to each other. That's a little annoying though, having to type out those names, which is why we have this variable type that can just give us a drop-down menu in the engine. We do have a little bit of a problem here though, and that is the pointer to incomplete class u blackboard component, and that is because we don't have that included. So let's get this include added in there. We'll be able to fix that issue very easily like that. And then we're going to check if both of those values end up being valid. So if we just put actors into both of those keys, this should end up being valid. Then I'm just going to copy over this line of code here. We'll have a float for the distance, and we'll calculate that with the f vector static function dist, and we'll get the self actor, actor location, the player actor, actor location, And then in our owner comp, again, that's a parameter from the tickNode function, we'll get the Blackboard component, and instead of getting a value as object, like we did before, we will set a value as a float. And we'll set the value for the distance to player key, which is the key that we made here. And again, we have to use the selected key name and then put in whatever value it has to write to that key. Now, it's quite important to take a moment here and realize that because we're using all of this getting value as object and setting value as key, in the end, when we go back into the engine in a moment, we will be able to put in keys that don't match these types. We can put in any key we want into any of these key slots. Meaning that if we put a object or an actor into this distance to player, it's going to try to write a float value into something that cannot take in a float value, and that's going to cause problems. So you do need to be aware of what keys you put into what key selectors and how you use them. Now, just as a little bit of an extra little fun thing is we can make a constructor for this as well. And if we make a definition for that, we can give this node a specific name, because there's a variable called node name, and that takes in a simple string here. And we can just call this update distance to player. That way we can see the name of the node very easily when working with it in the behavior tree interface that we were just looking through. And that is it for the code for this service. So when we put this on any of the nodes in our behavior tree, when we go through that node, this will run and it will update whatever keys we have put into it. Before you try to build anything to do with this though, this is a very important thing. You want to find your project name .build.cs. This is a C# file. And in here you will see we have a public dependency modules.addRange, new string, array, and then it adds a bunch of modules. In that, we're going to add in another module with the name gameplay tasks, exactly as it is right here. That will be needed if you are making BT services or BT tasks or decorators in C++. You'll be needing to add in that module. After you do that, you can build just like you can at any other time, and we'll remove the set default focus for now. And now we can add our new service, update distance to player. And when we select that, we get our self actor key, we get our player actor key, and our distance to player, which just happen to be set to the exact right things. But as you can see, I can put in any of the keys I want here. So do be careful about putting in the kind of key that you actually want to use there. Now, this service will run a certain amount of times per second. It will run as long as this selector is in the active path, but also it's not going to run it every single time, because a behavior tree, if it's just doing tasks and doesn't have any like wait nodes in it or whatever, can run a bunch of times, potentially tens to hundreds of times in a second. And you don't necessarily want to update all that information that often, because that's quite computing intensive. So what you can do is the interval between this running. So for the updating distance to the player, we actually want that to be run quite often. So let's run that every 0.05 seconds. So that will be 20 times a second. And we don't want any random deviation on that at all. So we're going to set that to 0. So now the self actor key will automatically be set to whatever actor this behavior tree is running on. The distance to player we are now writing to. The only thing we need to do is to make sure that the player actually has a value. And for that, we're going to go back to our base enemy controller. Just in the begin play function here, we're going to say that our enemy BT asset. For this, we will need to have a include for the Blackboard components. And the wonderful thing is, from an AI controller, you can just simply get the Blackboard components that this AI is using at the moment. And from there, we can set a value as objects. and the value that we're going to be setting, we need to pass in a name here. So do make sure that this is the exact spelling that you use. And then the value of that will be, we'll be using gameplay statics for that actually. So let's include Kismet gameplay statics, and we will get the U gameplay statics function get player character. And then we'll use this as the context object. And then we need to put in a player index as well, which for now is just going to be 0. Now, I think it's a good time to test whether or not any of this actually works. So let's go into our BP enemy here and open the full blueprint just because I prefer this visualization, and see the AI controller for this class is going to be the base enemy controller that we've just made. And we should double check it has the BT basic enemy behavior tree. So in theory, when we place this into the world, which we have that one in the content folder, just place it into the world somewhere around here. I guess this one doesn't really need the camera now that I think about it, but we'll figure that out later. We can start the game and we can run towards it, and it doesn't do anything because it's literally just updating its own values. So let's actually open up the behavior tree here side by side with the gameplay. And this will be a little bit iffy because usually I do this on a second monitor. But we can see the self actor is BP enemy C, all this stuff. Can shoot is false because we haven't done anything with that yet. And the player is the BP player C0. So that is exactly correct. The distance is 325 units, and if we move around, we can see it is updating the distance very, very well. And now that we're standing right next to it, it's 68, almost nice. And when we run away from it, it increases. So, and you can even see if I show you right here, right now, we're under 1500 units away. 1500 units might be quite a little bit too much. So it should execute whatever is in this sequence, but if I run away, you can see it adds in this little red block over here, meaning that it now notes that, hey, this is no longer a true statement, so this decorator is now going to return false, and this sequence is not going to run any longer. So now what do? If we are less than 1500 units away, we want to shoot, that's fine, we'll make that in a moment. Otherwise, we're going to be moving to, and then we want to set that to player. So we'll just move towards the player until we're 1500 units or less away, and then we'll shoot. We'll actually change this back to 1000, and we'll copy over this decorator here and say that only when we are within 3500 units, which is quite a lot, will we be moving towards our player. Otherwise, we will just stand still for the time being. You could make a little system here where it just like patrols around to a random location. We're not going to do that right now here today. What we're just going to do is we're going to have these things stand still until they're close enough to us, at which point they're going to come running towards us, and if they're close enough, they're going to start shooting. A little note here, I did put this on the sequence. You can just put these on the tasks themselves. If you just need it to be one task, you don't need to put like a sequence or a selector node in between. That's entirely unnecessary. And honestly, I just spent about 2 hours trying to fix an issue, and I think it's just a bug at this point. Because I have my behavior tree here, and it doesn't work until I go into that enemy controller and I change any random one of these options, like once player set. Has nothing to do with this entire behavior tree stuff, but when I change that, it then starts doing the behavior tree stuff, so I only have it chasing me around now. That seems like a bug to me, so I'm going to assume that you guys don't have that, because none of my other projects have that either, and it's the exact same code. But of course we want to add in that other task. So let's see if we can make that. So let's make a new C++ class here. And this one will be coming from the BT task. So the BT task node. And this will say BTT for behavior tree task enemy basic shoot. For this, we need to put in a function with this signature and this return type that I'm going to add in right here. So that will be a EBT node result type execute task behavior tree component node memory. That is the exact signature of what we're going to need. This function will run whenever our behavior tree gets to executing this specific node. So, of course, that's going to be quite relevant. And for this, we want to first get the controller that this behavior tree is running on. And from there, we can get the actual character that that controller is then linked to. So the way we do that is we make an AI controller, and we just get that from the ownercomp.getAIowner. That gets you an AI controller back. And from there, we want to include our base enemy character, because we're going to make a variable for that, which we'll call simply enemy. And that will be a cast, and we've done this about 1 million times, so I'm not going to bore you through it too much. And what we're going to put in there is going to be our controller's pawn. So we do controller, and then we can get pawn. And for that, we will likely need a include for the controller itself. So we include AI controller so that we can actually use that line of code, which is kind of a requirement. And now we have a reference to a enemy character. From there, we can simply say our enemy, we want to shoot bullets. Now, we need a rotation or a direction for what direction we want to shoot in, of course. For now, since we will be most likely chasing the player anyway, the easiest way to do that is we'll just use the forward vector for our actor as it is, and that should just shoot in the direction that we're facing in anyway, and that should work decently well. So get forward vector. And this task, while being pretty rudimentary, should really do the trick. So let's compile that and see if it works. All the navigation related bugs aside, because of course, hopefully you guys won't have those issues. Basic enemy shoot is now a task that we can put in. So we can say that, and we can put our decorator on it for the blackboard, and say we want to shoot only when our distance to player is less than 1,000 is what we're going to go for at the moment. It's going to go through and update the distance to player. I just had a different service on that, if you noticed, that I made during debugging, which didn't end up being actually needed. It's going to update the distance to that player, and then if that's less than 1,000, it will shoot. If it's not, it will move towards the player. And let's change the observer abort for this one to lower priority. That way, when this one becomes true while we are chasing the player, we will start shooting instead, and we'll stop moving around. So now when we start playing, we should start seeing him shooting into a direction in front of him. Then when we are far enough away, we should see him stop doing that. And he doesn't do that anymore, indeed, and those are all the bullets. And then we have that bug where he doesn't try to chase us unless we go into his enemy controller, and we change something around here, and now he starts to chase us, and you can see he starts shooting at us as soon as he gets in range, and now we are dead. So we really should put in some code to deal with resetting the level when we die, but for now that will do. So maybe 1,000 units is actually a little bit too much, as well as let's go into the enemy here and change its time between shots to something a little bit more reasonable, like 1 second. And let's change this to like 750, so that it just has to be a little bit closer before it starts shooting at us. And once again, I really don't like this bug. If I figure out what that bug is, I will put it in the comments below or in a future video, but for the time being, there's not much I can do. And now we have an enemy AI that we can shoot at, we have to dodge them, and we can kill them. So that's the basic idea of coding an enemy AI. we have used the behavior tree now. We've made a service, we've made a task, a decorator works in much the same way. So for now, that's gonna be it, and next time we'll do something else exciting. I'm going to spend another couple of hours trying to hunt down that bug, and maybe, just maybe, I'll figure it out, and there will be a transition out to an extra clip of me explaining the issue. Some very, very good news. It turns out that actually I am just an idiot, and the reason that everything was going wrong is that in my enemy controller begin play, I forgot this little line of code. Super begin play. It wasn't running the begin play function on its parent class, which is the thing that enabled everything to work. So now you can see it'll try to move towards me and I can kill it, and definitely I do need to tweak some things like the camera on the player definitely needs to be a little bit further away. But that's a story for another day. I just wanted to finish this up by giving you guys the answer as to what my idiocy was. And on top of all that, something that I also should highlight is the player setup input component. I moved those to the actual player class rather than the base magic character class, as well as the whole set actor rotation from the movement and the shooting rotation. That also is now only on the player class rather than the base class, because the enemy is going to need separate logic for all that anyway. So that was also interfering with the rotation, and this just, I didn't need that on the other class, and it felt like it might be interfering, so I put it on the player class as well. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. And a special thanks to my Cave Digger tier Patreons, Sir J. Thomas,